I had a student ask me about question 3 on the 10-6B homework. So question 3 is asking about how to multiply two functions together. So we're going to multiply f, which is 3x squared minus 12x plus 9. And we're going to multiply that times g, which is x minus 3. And now you have a choice about which way you like to multiply. Some people like to multiply by distributing, and some people like to multiply with a box. And you just have to kind of decide which one is for you. I will show you how to do it with a box. If you want to see how to do it with distributing, you can ask, and I'll make another video. But if I'm going to use a box, because that first polynomial has 3 terms, I'm going to have a 3 column and then 2 row box. So on the top of my box, I'd have 3x squared minus 12x and positive 9. And on the side of the box, I'm going to have x minus 3. Then I'm going to multiply to fill in my box, remembering to add exponents, and that there's an invisible 1 exponent on some of these terms. So I'd have negative 12x squared, I have 9x, negative 9x squared, positive 36x, and negative 27. My next step will be to look for like terms. So I see some like terms here. These guys are both x squareds, and then I also have some linear terms. So I'm going to combine those for my final answer. So this is what I would type into Pearson. I would say 3x cubed, because that's the highest exponent I have, minus 21x squared. I don't change exponents when I'm adding like terms, plus 45x minus 27. And so that's my new polynomial. That's my new function. That's the product of those two functions. The next question asks me what's the domain of the result. This is a cubic function, and there's nothing in here that's going to stop me from plugging an x in. You could also graph it if you want to see what it looks like. But the domain is going to be all real numbers. In interval notation, that's written as negative infinity to infinity. In words, it's all real numbers. All right. I hope this helps. Please feel free to ask any other questions you have.